Alright, section 11.6, video number 3. We're going to look at an example that uses the parallel lines proportionality theorem. And really this is very similar to the triangle proportionality theorem, except we don't have a triangle. So the theorem says that if three parallel lines, so our parallel lines are FJ, GK, and HL, intersect two transversals. So I've got transversal FH and transversal JL. Then it divides those transversals proportionally. So the segments that it divides it up into have to be proportional. So basically what this tells us is that since these three lines are parallel, we've got these three parallel lines here, 1, 2, 3, that it's going to divide the two transversals. So here's one transversal, and here's the other transversal. It's going to divide those transversals proportionally. So the way we can write our proportion is FG divided by GH is equal to JK over KL. Now there are other ways that you could write this proportion that would work. The way that I wrote it here is based strictly on the theorem. So let's go ahead and substitute in what we know. We know that FG is 28. So we've got 28, and GH we don't know, so I'm going to make that X. And JK is 30, and KL is 25. So we've got our proportion. I'm going to go ahead and cross multiply. So I have 30 times X, and 25 times 28, which is 700. Divide both sides by 30, and I get that X is equal to, so what we were solving for is GH, so X is GH, which turns out to be 23.3. Okay, now I'm not going to go ahead and solve it, but I'm going to set up another proportion for you that we could also use. Feel free to go ahead and solve it. Make sure you get the same answer. So another proportion that we could use is we could do FG over JK is equal to GH over KL. So this proportion would also work. If you want to just double check that, go ahead and substitute in the numbers we know and solve it again for GH, and you will in fact find that you'll get the same answer. Again, write down any questions that you have and ask your teacher the next time you see him.